Here we are on the bench again for trying to test this hair dryer. This is not a common thing to repair this kind of stuff on my bench, but when you have to do it, you need to do it sometimes. So I just use my galvanic protection for to see just the motor rotation, if it's okay or not, and it doesn't work actually. The motors suffer about problem of turning, the shaft not turning as we can expect from a hairdryer. It has something like stuck shaft on the starter. So actually the resistors inside for the heat works nice. This is not coming from the heating element on this hair dryer. So we need to dismount it. The screwdriver needs to be Stars or Phillips screwdriver, and it doesn't fit properly. But we need to force a little bit because there is a kind of break in the center of the screw. But with a little bit of patience, you need to have it. So okay, let's clean my hands. There seems to be a little bit dry. I don't like that when I'm walking. And so this is not hydroalcoholic gel, but this is just a soap without water. I'm not afraid about the coronavirus when I'm working on the bench. So let's try to dismount this one again. This is not the first time I dismount this one because when I had it, it has connection trouble. I had to make the cord a little short, a little bit, for to make a new connection. And here, as you can see, there is no real problem about the free shaft of. Here you can see the fins seems to be well, and I try to understand why, despite all these facts, these motors won't turn on. It turned on, but he won't take the turns at height levels. So we need to dismount it for to try to analyze what it has. The screw have the same length? Not. They have not the same length. We need to be sure to not to confound them when remounting if you have a success on this repair. So it's a nice little motor for hair dryer, but what you need to understand is this hair dryer is a height brand hair dryer. It costs actually currently, something like $100, and I don't know if it's worth to repair this kind of stuff, but we need to analyze the issue coming from this hair dryer, and of course maybe the repair costs not expensive, and if the repair is pricey, of course, but we need to try. We need to understand what happens with this, and maybe it's worth to repair. Actually, as a technician, this is in my nature to try to repair something. I do not calculate with the price of what the repair can cost, or if it's worth to repair. It's in my nature to repair something and some stuff, because it's a kind of philosophy, I think. So my first doubt is about simply the diode, because on some circuit like this you will have a diodes, and in some hair dryer you will have motors supplied with a continuous current coming from filtered mains. There is no capacitors, but sometimes you can find a motor with a little diode for to use it like a DC current motor. In this case, this is not the case. The motor uses the mains, completely the mains for working. So my famous Anning 8008, I need to tell some information about this little multimeter. It has some trouble on the rotary buttons. Sometimes it doesn't work very well, so be careful with this model. I told lots of good things about Annings, but I'm a little bit disappointed about the 8008. So the motors won't turn on properly, and the diode seems to be okay actually. So I think this is not the diode. Here maybe the resistive heating element seems to work nice actually. This is not the issue here. So when you can check, what can you check when you have a motor sticking the shaft on the rotors? It's a little bit tricky thing. So I just think what I'm going to do here. So for to be sure about the diode, I'm going to dismount a lead of this one and test this diode separately from the PCB, because I'm afraid it can give a false result, because maybe there is some as you can see, the diode is here. This is a big model actually. This diode is used here to give all the sinusoid to the heating element, or only half of this sinusoid for to give less or more power. This is one of the systems they use here for to choose the power of the hair dryer. So need to desolder one leg of this diode. Of course, you need some caveats when you are working on this kind of stuff. Never let your hair dryer connected to the main. Of course, here I used a galvanic protection with a switch, with on-off switch button on front, and very easy for me to disconnect my galvanic protection when I'm working on the main like this. This is not really the main. This is a protected main. So if you put a connection with your finger, you will not be electrified or electrocuted, because you absolutely need this kind of device. This is one of my first tool I built for my bench. This is a homemade, of course, but it gives a very nice result for me, and for to work safety. It's I think there is no enough caveats about this kind of danger coming from the main, and of course there is no only the danger only the main, but also when you are testing and checking soft components, you have some exploding components. Mostly when you're working on the main, you can have a very explosive component, and I had some trouble with it in the past. I had some trouble with this. A transistor exploded in my face, and I have some blood coming from my face, and so sometimes you need safety glasses also, not only galvanic protection. So as you can see, the diode seems to be okay. This is not a problem with the diode actually. I don't really like this multimeter because it has some issue sometimes. Sometimes it has some issue with the rotary button. There is a bad connection due to greasy contacts. Actually, you need to dismount this Anning 8008 and clean the pads under the rotary button to have a nice result. I don't know why, but the manufacturer put a greasy past, and it's make some bad contacts when you're choosing your caliber. So here I have dismounted the sleeve of the motor, which contains the brush. The brush is made by something like graphite or carbon. I don't know exactly the material used, but it's kind of carbon or graphite, and it's a little bit strong, and it makes the contact between the the current and the collectors. The collector is in a copper, and also it's a kind of fragile component. The rotorism is very fragile. So if you have a badly adapted brush, you can have a wear very premature of your collectors. So if you have to change some brushless on a motor like this, you always need to take the more soft brush, because if the brush is not soft, it will wear the copper of the rotors, and it's not a good thing. But I did some mistake on this repair, because I don't know exactly what happened with this motor. I don't know why it won't turn on. It's turned on, but it won't physically turn. And I'm trying to understand if the brush is able to sleeve on the housing, and this is what I'm trying to do with this fine screwdriver actually, because my doubt is about if this brush is stuck on the sleeve, it cannot give a good contact. And also I made a measure with the ohm meter between the sleeve and the end of the brush, and I found a height resistance. And you cannot see you cannot see on the camera, but when I did some tests before, I see some smoke coming from the brush and the sleeves, the brass sleeves. I think this is a brass metal. So what I think here, because I think there is a bad connection between the brush and the brass sleeve. This is my first doubt here. So the connection of the diode or the deconnection of the diode have nothing to do with this. So I decided to reconnect it, because as you can see, as you saw before, there is no issue with this diode actually. So okay, let's test again and see how it reacts. This behavior is not very normal. I have 3 power available on my galvanic protection, and the power here is at the full tilt, and it doesn't want to turn correctly. It's look like it have a break on it. This is a contact cleaner. This is not a good idea to put some product on high voltage like this. But okay, I think this is not more dangerous like this. So it won't turn correctly. But the starter becomes very hot, and the heating elements stay cold actually. This is not a problem with the heating element. Just what I'm noticing here, this is the motors comes very hot, despite no matters about the selection of the switch. I feel some heat coming from somewhere, but I don't know exactly. This is a tricky thing to repair this kind of stuff. This is not completely faulty, this is not completely working. So this is not the easy way to understand how something works here. Okay, let's try this contact cleaner. This is another product with another quality. I think maybe it's give more result. Maybe there is some dust or some grease on the rotors, on the collectors I mean. Yeah, it always turn at the same way. Always turn in the same way. So it's a little bit hard to understand. So what I'm trying to do here is to move a little bit the brush, but it doesn't make any sense here because no. This step I don't really understand what happened with this motor. It's a tricky thing. Lots of spark here coming from the switch. So there is, I can feel a little break on it when I turn it with my finger, and the stator is quite hot actually. I cannot touch it with my finger. So it's very hot. I hope there is not a short on the winding on the sides of the stator. Again, a little bit of product for to try if there is a magic result, but I guess there is no issue for that. Always the same result. Oula, you can see some smoke coming from the motors. This is the product. The product I make here, I made is burning on the collectors. I think this is not a good thing to put some liquid stuff on it, even if it's electrical components. So let's try again before to drop this idea. Why not? Let's go to the end. So I try here to clean the copper. Maybe there is some bad contacts on the copper. Maybe there is some rust on the bearings. this is on this kind of motor you will not have a real bearing. So this is a ring of brass. Sometimes this is just a ring of brass, and it's very hot. So much hot is not possible to handle with this with your finger. From the start, we are always on the same step. I don't know why this motor doesn't work. Maybe there is some issue with the capacitors. And my multimeter gives me very strange results. With the probe not connected to anywhere, there is some result on the... So let's see with this lamp if the heating elements have something strange, but there is nothing, of course. Let's disconnect it and try to see more closely about this little PCB. Okay. Let's connect here the probe on the heating element. This is the heating element I'm testing here. Yes, this is the heating element, and you can see 6 ohms. How to handle this stuff. So let's change a little bit the angle and try to see more clearly what happens here. 56, and the total is about 110 ohms for the heating element. So the heating element is nice actually. My doubt comes from the motor, and nothing seems to be faulty on this PCB. It's a nice made actually, and this is a high quality brand, and you will not be disappointing. Sorry for this kind of made. Okay, I changed the multimeter for my workbench multimeter because I have a doubt on this Aneng 8008. Sorry for this, because I told a lot of good stuff on this Aneng brand, but because they send their multimeter with a little bit of graze on the rotary button, it gives some weird results on the display. If you have some issue with this multimeter, don't forget you can dismount it and clean the pad and the rotary button to make it more reliable actually. So here I have a doubt on this diode, so I'm looking for a new diode on PCB to test it. So let's dismount a diode and check it before to dismount, of course. We have some few diodes available here, because I always have a doubt on the diode on the hairdryer PCBs actually. So try to dismount this one now to replace it and see if it can give, despite my check, if it can give more results actually. I hate when the lead of the components soldered on the PCB are bent under the copper. It's a pain in the neck for to dismount this kind of stuff. You need to force with the chip of iron. But what do you want to do? They bend the lead of the component for to make it for to hold it on the PCB before send it to the wave soldering. So unfortunately you cannot see the result of the workbench multimeter because I stopped to use the anning. So I think I don't see a real issue on this little PCB. What can happen with this motor? It can turn with the finger, but not really nice when it's powered. So I'm checking here the context between the winding of the stator and the brush. Actually, maybe it's there is some issue on it, but I don't see anything like that. Maybe there is some dust on the sleeve. No, I don't know actually. I'm always checking and trying to understand. The brush is always able to slide on the sleeve, on the brass sleeve. Actually, there is no issue about this. They are not stuck. So. So I'm try to clean the copper of the collectors with this rag and try if it's able to give more best result. So the copper seems to be clean actually, but maybe what I need to do is to dismount all this motor for to be sure about the check of this copper pad of the collector. So I have dismounted the motor here and connected directly to the main, to the galvanic protection. It turns at the same way, always at the same way. So that means then there is nothing on the PCB faulty for to explain why this motors turn like that. It's you can see the diode on the connectors here. So I have a doubt on this winding, and so I measure the reactance, the inductance, sorry, for these motors, and the two winding seems to be nice. So they seems to be not short circuit actually. So I have to dismount this stator for to see directly the copper of the collectors. But I have no other good socket. Maybe there is no room for to introduce this little socket until the screw, till the bolt. So a little bit of patience for to dismount this one. I think further to make a little groove with a saw for to to put it or to remove it more quickly. Just a little bit groove, a little groove with the saw on the head of the bolt for to use it with a screwdriver simply. I don't have the good tool for this, so we need to be patient this time. And so let's try to understand how this kind of stuff is able to be dismounted. I don't usually work on this kind of motor, but I'm learning here. I'm learning a little bit. So there is a little bit of brake on the shaft. Actually, I can feel it with the finger. It's not turning very freely, I think. Okay, how to dismount this stuff? And so this motor is dismounting just like that. You need to pull the back actually, and you will have the rotor and the collector just in front, and you can see if the pads are correct. And it's always the same problem. It doesn't want to turn very freely. It looks like it has some brake on the bearings, and the starter seems to be nice actually. So I have dismounted the brush, and you can see the sleeves on the bench. They are brass sleeve, I think. I have drilled this kind of I have made some little hole with a drill on it, on the brush, because there is no real electrical connection between the brush and the sleeves, as you can meet on another kind of electric motors actually. And my guess is there is maybe a bad electric contact between the brush and the sleeves. So if this is the case, I'm going to reduce this resistive electrical contact, the bad electrical contact, by adding a little wire connected directly on the brush. And for this, I'm going to use the little wire you can find on the headphones. When you have hold headphones, you can use the wire on the cable for to use, because it's a meshy wire, and it's very supple and very nice for to use on this kind of application. Of course, you need to do it when you have not lots of power, because this is a very thin wire. And it's very supple. This is the best idea, sorry, for to try to improve the electrical contact between the brush and the collectors, and the copper collectors. So what I'm trying to do here is to put melted tin on it, for to stuck this little wire on it. And as you can see, I make the tin melted with the soldering iron, and when it's melted, I put the wire on it. And so you will have a little contact on it like this, but it's very hot actually. So this electrical contacts product for to remove some grease and some dust on it, because I think they are responsible for the bad electrical contact between the brush and the brass sleeve. So this is a MacGyver way, I think. So I have to do the same thing with the other brush. Need to thin the little wire before to put it on the brush. For this you need a good power on the soldering iron. You don't need a high temperature, but you need the good chip, because you need to heat up quickly, nicely, but not too much, because if you heat up the tin a lot, you will have a boiling tin, and this is not a good thing for if you want your chin stuck on the hole on the brush. You need to use a 300 degrees temperature. Actually, I did the mistake, so I know you need to use a correct temperature, not too much hot, like 400 degrees. So in this case, the wire and the brush was too hot. I need to wait a little bit to chill it before to test the wire on the connection. So to make the solder more sticky on this, I just scratching the hole with a little cord. This is a guitar cord. Coming from a old cord of a guitar. So this is just to permit to the solder to stuck in place, because if you have too much soft area on the hole, this is not actually. If you have the good tools, you need to make a hole bigger on the depth. Because the hole you have on the brush, the first hole need to be little unlike the hole on the depth before, because if you don't do that, your thin will not stuck in the hole. This is one of the solutions you need to make it nice. You can see here the tin boiling, because there is some flux on it, and this is the flux which is boiling like that actually. This is a real-time video actually, so you will see all the mistakes, all the time need to repair this kind of stuff, even when you are connecting a wire on this brush. Okay, you need to redo again. So okay, this time you need to try to make your wire and wait a little bit before to handle it. Just wait. For to tell the truth, I think I'm using this product to make it chill very fast, but it's still hot. So okay, now I have a brush connected directly with a wire, and it's permit to me, and it's permit to be sure to have a nice electric contact between the sleeve and the brush. I think it was not a problem before, but there was maybe some products between some grease, or I don't know what exactly, between the sleeve and the brush, which don't permit the good electric contacts. This is the reason why you can see when the motor is turning, you can see some smoke coming from the brass. And so let's try now to mount this brush and the sleeves on this little motor. It's a little bit outcast. So the copper is the brush is inserted on the sleeve, as you can see, and you need to calculate the good length for the wire, because I have made a little mistake here, because when you choose the length of the wire, you need to choose it when the brush is always on the sleeve. If you have the brush out on the sleeve, you will have some difficulties for to put it correctly on the motors. So I didn't correct it at the time. So
t'as compris? T'as pas compris? T'as compris la chienne? Quel bas?
So it's not a simple thing, it's a doubting task actually. Actually, it's a doubting task from the start, I think, because this motor seems to be nice, and for to understand what happened with it, actually, it's not very easy, because for me, it has to work properly. I don't understand why it doesn't work. So this is my last solution, of course, because if with this it won't turn on, I don't really know how to do more, because I have tried all the solution here. So my last doubt is about the bad connection, the bad electric contacts between the sleeve and the brush. So this is the reason why I choose to put this little wire to connect directly the mains directly to the brush. So you need to solder the mesh wire on the brass for to make the perfect electric contact. This is my favorite soldering wire here. This is a 0.7 millimeter soldering wire, and it comes from Dijon. It's from France. I love this wire. This is my favorite soldering wire. And so it makes a very nice soldering joint, very shiny, very beautiful, perfect for me. I love it. So first let's try the resistive load, and you will have a nice contact due to the brush properties, and it's normal to find another result than the zero. You cannot find zero on the brush, because zero is made by carbon, and carbon is not a perfect conductive of electricity. So let's try to do with the same with the other brush before trying to remount all this mess on the hair dryer. Actually, this is not the hair dryer of my wife, of course, because she has she has a more recent model, and this is a old one. This one comes from a flea market, and it was sent to me. It was sold to me for not a very expensive price, something like few euro, and it has some issue contacts on the cord. It was very easy to repair, and I have it from years, from 2 years now, and recently when I wanted to use it, it won't turn on. So I think maybe I was hesitating because I don't know how to do with a so inexpensive product. When you have so much inexpensive product, what do you want to do? Do you want to try a repair? Do you want to buy another one? I think maybe this is worth to try something to repair, because if you don't take a glance on any devices which has some issue, you cannot be sure about the possibilities to repair or not. So I was ready to throw it on the trash, but this is I have nothing to lose with this little devices, and so if I can repair it, it's a good thing. What you can see here, this is a very corrosive flux. This flux is currently used on plumbing, you know, when you have some copper tube to solder for the water. And I use it when I have some difficulties to make a good soldering joint on any product. This joint, this flux, this blue flux is very nice to help you to make a very hard connection. This is not electronic flux. This flux is coming from plumbing projects. Okay, this is not electronic flux, but I use it when I have some difficulties, and it's worked very, very, very nice. And also I use it when I have some copper wire, and when it's coated. You know, when you have a coated copper wire, you can use this kind of flux to help you to make a very nice and quick connection to the PCB or to the wire or to another connection. This is a very nice. If you haven't this kind of flux, it's not very expensive to have it. You put it on the syringe like this, and you will have a very nice help to make your soldering joint. So
les sous que tu as ramenés dans l'enveloppe là, ils viennent d'où? Dis-moi la vérité.
I finished to solder this wire to this brush actually. So the next step is to put it on the motors, and of course, because I have make a mistake, you have to choose the length of the mesh wire just as possible to let the brush inside the sleeve. As you can see, it's a pain in the neck to remount it, because the brush is opposing the square of the brush and the square of the brass copper, and it's some bullshit. So I had to manage to remount it without breaking anything, because I checked on all my junk. I have no another piece like this for some repair of for standard repair, because I have not another contacts like this. Actually, this is not a brushless motor. This motor uses a brush, because this technology is used again to make it more simple, because if this is a brushless motor, you need electronic to drive it. So to keep the price correct for lots of equipment, this is not, the brushless motors is not a component you can find easily on the height brands or current brands. So actually my drill is brushless motors, and it's a very powerful drill. So brushless motors are used for very high efficiency, and they are able to have a very long time scale, longer life scale, because they have no brush. But of course you will always find trouble coming from bearings or other stuff like this. And this kind of stuff, the electronics is very sturdy, and you will not meet any problem coming from a three-phase driver about some brushless motors. So I'm struggling here for to make this brass on this housing, and this is because simply I didn't adjust the length of the wire correctly. This is one of mistakes. Try and try and try again. And here we go, it's good. After some few times of struggling. So you need now to put a wire between the brass copper, I mean the brass, and the winding. This is a contact you can see in front. You need to redo the contact between, because I had to break it to remove the brass housing. So I prefer to use a regular wire instead to use this little wire coming from a winding. So I am using this flux, and this flux has helped me to work very quick and on a difficult area. So it's a very, very, very nice flux. I love it. But I can recommend it for electronic application, because I don't really know. I didn't make some test on it for the moment for to see if there is any conductive, because the flux you're using on electronic have not conductivities, electric conductivities, and the flux you're using on plumbing has an electric conductivities. So you need to be very careful with the flux you use. So this blue flux is used on the big connection, because I will not have any problem of conductivities here, but you will not use it on the PCB, for example. Or if you use this kind of flux on the PCB, you need to clean it very nicely after working. So I'm just a little check again this winding, because we are never enough sure for this kind of repair. Thin the wire a little bit and solder it directly from the winding pin to the brass. Let's cut the good length. And so solder it again. Okay, it's enough. It's enough. So let's do the same thing on the other side. Soldering the winding connection and the brass copper directly on the brass copper like this. and cut the wire, as you can see. Okay, that's enough, I think. So there is maybe okay, so let's tighten a little bit this screw, because the turning ability of this motor is depending about the height of the screw, which I think this is a parallelism problem actually. And so let's connect the main and the galvanic protection to try these motors again. As you can see, this is the suspense. It is working, but all the power, I think it will be okay. That's okay. It seems to work nice now. So let's try again. I think it wants to turn quickly, but it needs a little lapping, I think. So let's add so chemical product to help him, and it's not what it was not what I expect, but, so a little bit dangerous. So it works nicely now. Let's reconnect it again, and it seems to work at full tilt apparently. So it works nice actually, with a lot of sparks coming from the collectors. Okay, don't forget your safety glasses, because we don't know what can happen here. So it seems to work nice now, and try at full tilt. Yes, okay, it seems to work nice. So for the deduction, I don't know exactly, but I'm pretty sure there was a bad contact between the brush and the copper on the brass housing of the sleeve, and so because I have a doubt on the grease on it, I chose to wash this motor like we do for crockery, and with hot water, and so need to clean it. Wash day tomorrow, so let's dry it with another hair dryer. This is not my hair dryer, this is another hair dryer. This is a loan actually, and you need to make this motor very correctly dry, because electricity doesn't like the water, and vice versa. No water inside, no more, no grease, with soap coming from crockery. This is a crockery soap, simply crockery soap. I think it's enough to make it clean, because I guess there was a lot of greasy components on this motor, and it prevents good electricity conduction. So I use this fan for to chill, for to make the starter cooling a little bit, because it's running here at full tilt. The light you can see was coming from my galvanic protection, because this is a bulb limitation. There is some bulb inside, and I use my safety glasses for to work properly. And here, meanwhile, the motor is turning at full tilt. I am tightening and untightening. I'm releasing this screw or this bolt, because corresponding to the tight of the screw, the motors change the turning abilities. There is some parallel problem with this motors, I guess. But we can find a compromise for to make it usable again. So you need to release a little bit of the screw here, release a little bit of the screw here for to make it correct. And as you can see, I make a little groove with a saw, because it was hard to turn this bolt with a normal wrench, because you need special tools for to do that, actually, because you need special tools for to do that actually. And so the fan prevents the starters to be hot too much. This is the reason I'm using this fan powering with my with one of my power supply. And here I'm tightening the screw with a little plier. So okay, it seems to turn very nice and quick. Lots of noise, of course, because this is the good way which this motors need to work. So what can be remains to me again? Try. Okay, for to do it right, I think it's will be nice to tighten this screw at the maximum we can, or untight, I don't know, because I need to hear a nice noise coming from this motor. You can use the sound coming from the motor first to guess if the motor is running correctly or not. This is a way to repair this kind of stuff, but this is not a current way, I think. So let's turn and turn again until we can hear the good sound coming from this motor. Yes, it takes sometimes it takes a long time. It takes a while to make some adjustments. Adjustment is an affair of patience and tricky things. It's not so easy actually. I always feel that this motor is not running at full possibilities. So let's try again until we can hear the good sound. I think maybe it's enough of adjustment. If there was not this fan front of me, I cannot handle this motor in my finger, because the stators will come very hot, And of course, when this motor was running on the hair dryer, the flow of the air coming from the front of the motors go in the back, and in the same time it's make a cooling system for the motors, because it's very powerful motors actually, and the fan itself is able to chill the stator when running in the housing of the hair dryer. This is how these motors can be very little for 8 power, and it can be relevant to see this kind of stuff. So let's make some adjustment again. Sorry for that, but I feel something is going wrong with this parallel shaft and parallel stator, and I don't know why exactly. I don't know why. Maybe it's a little bit old unit, but we have no another spare for that. We need to repair this motor, because there's no another way. There is no solution for to do that differently. Make some adjustment again. Try why this motor is not running at full tilt. Make some adjustment again. You can see the changement of the sound when I'm touching the screw. The sound is testing, because when the parallel shaft is not perfectly parallel to the rotors and to the stators, it makes some ribbing, you know. It makes some ribbing with the bearing, and it prevents the shaft about running freely on this motor. So here the motor seems to run very well now. It's running very fast. So I think this motor is correct now. As you can see, there is no spark anymore. The sparks are very, very little. And it runs very nice. It runs very nice. So quite hot, but it runs. It remains to me to make some cleanings and remount it, all this stuff. So of course I need to make the same test with the fins, because of course this is not the same thing when the motor has nothing on the shaft and when it has something. This is never the same thing. It's quite hot actually, and okay, just be a little careful, just be a little careful for this, because it's quite hot, and of course the fins need to be screwed with a little room underneath. So let's connect it again and see how it reacts at full power, of course. So it runs nice. I don't see any issue anymore. There is no sparks, and the shaft seems not to be stuck on the stator like it was before. So Okay, it seems to be nice now. I'm going to try to remount this.
C'est ce qui me semblait.
So, but I feel, I think then I feel it needs some cleaning because it's very hellish to work in this condition. But anyway, so let's try to remount this stuff and see if it works nice. So I put little marks on the connector to put it correctly on the good connectors. So this is invisible marks, but I can see it to make it more possible at the same as it can. So let's connect it on this connection. This is the other wire. The place on this connection is the other wire, like this. And so the same thing for the other wire, of course. And so let's remount the puzzle now. This is a kind of puzzle. So I hope it will work now, but I need it to be correct when remounting the stuff. Why? Because if I put something wrongly, it's with forcing, it's not a good idea. All the stuff need to be correctly inserted without forcing. Always learn to work without forcing. Forcing, when you're forcing, it's you are in the wrong way. Forcing, you never need to force anything. Where this is a thing you will be learning when you make some mechanical repair, actually, because all things need to fit without forcing with another things. You absolutely not need to force. If you need to force, that means you are doing something wrong. So this is the height length screw, because they are different from the another. You need to be wary about that, for to not put the bad screw on the bad place. The most famous case is about the iPhone. When people put the bad screws on the iPhone, they break the iPhone with the too much long length screw. This is a famous way.
Qu'est-ce que t'as dit?
Oui, t'as laissé.
Ah,
Ouais, il est fragile là quand même.
non, mais ça c'est pour faire les couleurs.
Put the PCB on the good place, and
Là, si tu
the
veux, je
wire
te
needs
construis un
to
fil de
be
fer.
inserted on the screws,
Et là, même s'il est cassé, il fonctionne, hein?
Ouais, il fonctionne.
like that. Okay. You need your fingernail as much as possible. As you can see, there is a tear-up on this cable. This is the proof I worked on this device before. This is where I made the ripper, the first ripper when I had this hair dryer. And so it can be tried now, but I think I'm going to finish this stuff and put the screw. This screw have not the same length than the two other screw. This is maybe this is important, you know. The screw have sometimes not the same length. On the center of this screw there is a brake, and my screw is not able to fit this brake. This is a little turret, you know, and it's hard to put my screwdriver on it because it's avoid the penetration of the screw on the hole of the. So just remove the shaft, the brake with this cutting plier for to remount it more easily. Just like that. You can use it also at home. It's a little trick for when you have this kind of stuff to break the brake in the center of the screw, for to use a classical screwdriver, as I'm doing here. So now I think it's going to be okay. Okay, and the screw is fit correctly with the screwdriver. So this is the last screw before testing it again, and this is the filter. But this filter prevents a little air. If you want more air, you can remove this filter, but you will have some dust and other stuff sticking on the heating elements, and maybe this is okay. What I noticed in this case, it's the hairdryer make another sound when you remove this filter, and I guess there is a charge loss when you are making this filter, but that's normal, I think. So let's try this hair dryer finally, and it works perfectly, and it's the exhaust is very nice. It works perfectly. But of course, it's not possible to use all the heating elements because my galvanic protection is not able to give more than 4 or 500 watts. So, okay, it works nice now.